Hello, this is Toby Ho, and I'd like to show you the Deep Zoom debugger I've been working on. The Deep Zoom debugger is a post-mortem debugger, and that means rather than trying to debug a program live while it is executing, you instead record what it did while it executes at every step, and then afterwards you scrutinize what the program did. This is a concept and a prototype, and it drew from a handful of key inspirations, which I'm going to list right now. Number one is Python Tutor by Philip Guo. Python Tutor is a beginner-friendly step debugger, which can step both forwards and backwards. Additionally, it gives a graphical depiction of objects, arrays, and dictionaries on the heap, and it is very helpful for learners. Another big inspiration is Brett Victor's famous talk entitled Inventing on Principle. In this talk, he demoed a live coding system that he built, which allows the program to not only go backwards in time, but also see all of a character's futures simultaneously. Also, he live coded the binary search algorithm with the aid of a side panel that immediately shows you the intermediate values of each variable as they change within the execution of the program. Now, the name and concept of Deep Zoom comes from Benoit Mandelbrot's incredible Mandelbrot set and the concept of fractals. Particularly, the idea that many things in life can be viewed from many differing levels of detail is something that has completely changed how I look at the world. Then I thought, what is a software application that is like that? And it was Google Earth. Google Earth, the most detailed snow globe ever. The Chrome Debugger tool CPU Profiler is another tool that exhibits a deep zooming user interface. It, along with the Chrome Debugger, are tools that I use regularly in my job. Probably for that reason, I took some design elements from each of them. Okay, enough preface. Here is the Deep Zoom debugger in action. In the top level, we see the entry point of the application. In this programming language, a mandatory main function is the entry point of every program. When we zoom in further, we see the details within the main function. On the left-hand side, we can see the line numbers corresponding to the original source code. On the right-hand side, we can see the intermediate values that are created by the program as it executes. The fib function, as you might expect, generates a number within the Fibonacci sequence. We called fib with the argument of 7, and it returned 13. This program apparently printed 13 onto the screen. If we want to see the details of what happened within the function, we can zoom in closer. Here, we see the execution of the fib function with n equals 7. It does not show every line of source code, but rather it only displays the lines that were reached. Whenever there is a function call, it shows its actual inputs and outputs on the right-hand side. Whenever there is a variable assignment, it shows the value that was assigned to it. And whenever there is a return statement, it shows the value that was returned from this function. We can zoom in further to the call of fib with n equals 5, and further to fib with n equals 3, and further still to fib with n equals 1. And here, finally, we reach the base case of the recursion, where the code simply returns 1. Let's contrast this with the implementation of the Fibonacci sequence that uses a loop. Here, you can see that the body of the while loop has been pasted repeatedly one after another. This is what happened naturally as the result of following the execution of the code line by line. This visual depiction gives a strong sense of chronology. It almost feels like a sheet of paper upon which someone has worked out the steps of a math problem line by line, and then finally arriving at the answer at the bottom. I like to think of this visual as an analogy to a very, very large piece of paper where the entire sequence of steps that the program took has been depicted. There's no need to step back and forth in time in the debugger because using Brett Victor's words, time has been mapped to space. That is all for this demo. If you'd like to learn more about the Deep Zoom Debugger, you can find the project at github.com/airportyh/play-lang.